Thank you, everyone, for dialing in for our fortnightly Kubernetes webcast series. This session is slightly different to what we're normally doing. We normally cover topics that are important around Kubernetes, how to do things, or maybe different options out there in the market to solve problems. Today's session is focusing on Platform9 and our latest release, which is 5.3. That's live in our free platform that you can get access to from platform9.com. If you want to click along and follow along, that's one way to get started. If you're an existing customer, you should already be upgraded. So without further ado, I'm going to jump in. These sessions are meant to be interactive. So if you have questions, please do ask. The better the questions, the better the session, I like to feel. And then you won't just be listening to me talk. You'll be potentially listening to other people talk as well. Today, it is just myself. As always, I have David in the background. I think we might do some Q&A together on this particular set of features as well, especially some of the items we've added to help people sort of get going with our APIs. So hopefully it won't just be myself today. And as an overview of what's in our 5.3 release, just to sort of set the scenes, Platform9 has been working on a SaaS managed Kubernetes platform since 2017. Doesn't feel like that long, but it has. And about 3 weeks ago, we released Platform9 Managed Kubernetes version 5.3. We run a SaaS management plane, so that was upgraded. And through our multi-version support, that means that all of our customers can, when they want to, upgrade their clusters and take advantage of any features that are new on the cluster side in that new release as well. So today we're going to go through and talk a little bit about the profile engine. I think we'll do that towards the end of the session. That's a new capability that Platform9 has been building out that's focused on essentially templating clusters and really helping sort of promote some GitOps or infrastructure as code methodologies within people's environments. So stay tuned for that. That also has a built-in drift analytics capability that will allow you to compare and contrast clusters and see where they differ. We'll also spend a little bit of time looking at our new support for both Google and Microsoft Kubernetes engines or Kubernetes services support. So the ability to import existing clusters. We'll go through quickly what that looks like and how that is done. Have a quick chat on the Platform9 CLI and also introduce people to the Platform9 VM template that we've released, an OVA file that people can download and boot up on their laptop, be it a VMware workstation, VirtualBox, or what have you. This is just a VM template that you can use to get up and running quickly. You could also use it to build out more clusters if you don't want to have to go and grab a Ubuntu 20 ISO or CentOS ISO. You can just grab this and get going. It's all ready to get started. So with that, I'm going to hit escape, and I'm going to go back to my instance of Platform9. Full disclosure here, this is running live on Platform9 free tier, as you can see here in the URL. This is a deployment I've had running for 18 months. It's gone through the entire journey with me. And as you can see down here in the bottom left-hand corner, it's running our 5.3 release. And before we jump into the details of that, I'm just going to do a quick intro to the user interface so everyone knows what we're looking at. And that means we'll all have a good baseline understanding of what we're doing. So this is Platform9. If you're a new user and you sign up, you're actually going to get taken through an onboarding workflow. That onboarding workflow will help you get your first cluster up and running, sort of targeting a single node if you're using a VM or a physical server. If you connect to the cloud, you can import anything from Amazon, AWS, or Google. Or if you like, we can also create what we would call a native cloud, a native Kubernetes cluster in either AWS or Azure as well, where we build out all the instances, set up load balancers and storage for you as well. So they're the options to get started. You can always delete it once you're in, but once you go through that, you'll land on this interface. Gives you a quick snapshot into what's running in your environment. As you can see, I've got a few clusters. One's unhealthy, one's actually converging. That means it's building. I've got a bunch of nodes, and then you can see a sort of snapshot into the pods and services that are running as well. If you want to see your user information or change your password, just click on your avatar. You can come into My Account and come in and update your password, create new tenants because we have multi-tenancy support, add users, stuff like that. To get back, just click on the name. Then we have a view into the environment as it's running today. So infrastructure is where you come in to see all of your clusters or imported clusters. Workloads is where you come in to see everything that's running in your environment, as well as access to container logs, so on and so forth. So to get started, I think I'm going to kick off with our ability to import clusters from existing Google GKE as well as Azure AKS. If you're existing or new, the first step to doing this with Platform9 is always to create a cloud provider. These cloud providers are pretty easy to get up and running. Just log in, come to cloud providers, click add cloud provider, and from here, you'll be able to choose which one you would like to add. AWS, we're using an access key and a secret key combination. So set up an identity within AWS. Either use our IAM policy that we've got pre-configured, or make sure that it's got access to the ones that are listed here. Put it in. It'll validate the connectivity for you, and then allow you to set some defaults, which we'll touch on later. Same process for Azure, just making a service principal. Make sure it's got the contributor role, plug in the details, and it will connect. And Google Cloud, you can make a service account. On our doc site, you'll see the requirements there. Paste the full JSON file in, or click upload to upload it, and that will create the Google Cloud provider as well. So that's pretty easy. On this site here, I've actually got all three running. So I've got Google, AWS, and Azure. Once you've set these up, you can always come in and upload the JSON files again if you'd like. So once these are in, super easy to get a cluster imported. Just come into imported clusters over here and click import. So the past couple releases, we've had the ability to bring in EKS. This release, we have introduced the ability to import AKS clusters. Exactly the same workflow for all three. You're just coming in, choosing it, clicking next. We're going to go out to that account and we're going to look at all the regions and then allow you to choose only the regions that have clusters running. If a cluster is already imported, you'll see them here as all marked as already imported. As you can see, mine are already all imported. So there's nothing to import here. If I go back, let's go to Google, import, same process. Choose a cloud provider, click next. We're going to scan the regions and the clusters, and you can say, hey, what's running where? All right, here's one. It says cluster 2, it's not imported. This one down here in US East 1, I'm going to talk about this for a little bit. So this cluster here, I can choose to import it, but you can see that it's on a private only VPC. What this means right now is we'll import that cluster, but we're not able to access any of the workload information. So it's basically a read-only view into the GKE APIs. So that's what is the cluster doing, what node pools and nodes that are in there, and that's essentially where the information will stop. The reason for this is because the API server is on a private network space, and we're in the process of building out the Platform9 communications tunnel that would be installed into that cluster and then dial home. So right now, if you want the full experience, we'll just require the API server to be on a public endpoint. I'm going to click next to import that. Once you click import, it's just going to go and grab that cluster and add it to the list of imported clusters that you can see here. And I'm going to dive into that cluster 2 and chat a little bit about what we're doing with these imported clusters, why we're doing it, and sort of, I guess, what's coming next. The objective here with Platform9 and bringing in external clusters is to be able to help users really centralize where they can just go and view their clusters. That's kind of step 1. I want to see everything that I'm running in a multi-cloud or hybrid cloud environment in one spot. So that's kind of the first step. The second step is, what is that infrastructure that is being deployed, and is that environment operational and healthy? So immediately we can see within all of our imported clusters, the node groups, the number of nodes within them, the instance types that they're using, and the location that node group as well as cluster is provisioned within. I can move over to nodes to get a breakdown of each of these nodes to see a little bit more information about them. I can also come to cluster details to see what's going on and how that cluster was set up. The next piece is here around deployed apps. There's also monitoring as well, is sort of the next layer of management that we've built this to support. So when people build a Kubernetes cluster, it's laying down that sort of base infrastructure for cloud native applications to run at scale. What happens though is there's always a number of add-ons that are required to either run and connect to people's production or development environments, be it pipelines, what have you. But also there's base applications that at Platform9 we like to call Kubernetes infrastructure applications that are sort of required to help you run and operate those clusters. And one of those is having a consistent monitoring environment in every single cluster. And that's one of the features that we have the support for when you import an external cluster, is you can come in, once that cluster is imported, come in and click monitoring, click enable, and we're going to go and deploy a Prometheus Alert Manager and Grafana stack, fully managed, lifecycle, dashboards, alerts are already set up. And that's going to go and deploy that into that GKE cluster. Exactly the same support for EKS. You can just come in, click deploy. As you can see, I've already deployed that on this one, so it's saying disable. And it will go and deploy that monitoring stack. What that means is when you drill into this, you can now see alarms here for this cluster, and also get a centralized view over here on the left under the monitoring tab. As I am now in the AKS view, just want to point out super quick, exactly the same approach to laying out these dashboards. So people that are doing a multi-cloud deployment, trying to make it as consistent as possible, but still using each cloud's native language. So node groups instead of node pools. Once again, here we've got an overview of all of the node groups. If we go to nodes, you can see all of the nodes that are running. And if you just want to focus on a particular node group, you can just filter super quick. Once again, details of the AKS cluster, what type of networking is it using, containers and services, side ranges, what logging is enabled within Azure itself, and any tags that have been deployed on this. As you can see here, we've got data on the cluster status as well as the API server status, which is important. Obviously, if that was red, there are going to be some significant problems going on in that environment. But importantly, once monitoring is deployed, the Grafana link becomes active, and you can click on that, and we're going to securely tunnel to this running in your cluster, no matter where you are in the world, right? I'm just logged in, web browser. I am not on any VPNs. All I'm doing is using Platform9 as a secure point to tunnel through into my clusters, and it's reading out in real time from Azure this monitoring deployment in Grafana itself. So there's a number of different dashboards that we pre-configure. This one that we're looking at is actually an individual host dashboard. You can see all of the nodes in the cluster are here. We can also click into the Grafana dashboard and start pulling up different information and different dashboards about that Kubernetes deployment. How healthy is it? How is it performing? Are there any problems? This is Kubernetes API service stats. Really great information to keep track of, making sure that the response times are staying within a expected limit, so it's not impacting the performance of your cluster or applications. And all of this is out of the box, right? All I've done is click deploy monitoring, and this has come up and is now performing. And you can just start consuming that information. And this is exactly the same process for clusters that we build on bare metal or virtual machines or in AWS and Azure using upstream Kubernetes and their native infrastructure components. Exactly the same data and dashboards. So really aiming to create a standard experience for anyone that's running Kubernetes clusters in any location they choose to run and operate. So that's one of the advantages of importing external clusters. If I come back here and click on the alarms tab, what this is going to do is it's going to go out and connect to Alert Manager on that cluster, and it's going to start pulling back a timeline view of alarms that are firing grouped by severity. That's part of that monitoring deployment as well. What this means you can do is very quickly get a centralized view for every single cluster, right? Even if you have a enterprise monitoring strategy that includes tooling for Kubernetes, what we've got when you deploy that built-in monitoring is a source of truth that you can leverage to go back and confirm data or quickly troubleshoot, maybe if you're remote and you can't get onto a VPN. But it also means that if people in your organization are able to build and deploy clusters themselves almost in a self-service manner, or maybe you've got developers and they all get clusters, you've got the ability to ensure that they all get the same level of monitoring deployed into those clusters, and they can quickly get in and troubleshoot any issues as they're writing applications, which is essential to productivity and creating that consistent experience. It also means that if they're going into production or staging, maybe these developers can then also leverage this to help troubleshoot any performance that are any issues that are happening in real time. As you can see, that's pulled all that data back. We can see all the alarms. It's just paginated here to 10. If I want to see more details about these, I can click on that. We get a pop-up. If this is an alarm that I don't want to know about anymore, you can just tell Alert Manager to snooze it. 12, 24, 15 minutes. Sometimes you've got some work going on, just like, hey, I don't want this firing anymore. Just click snooze alarm, and that's going to go and tell Alert Manager to stop notifying you about that and pull it off of the dashboards and reports for the time frame that you just selected. And the last piece here for imported clusters is the ability to use the Platform9 Helm service that runs in our SaaS management plane to also consistently deploy any Helm packaged application as well. So it's taking a step further from the base add-ons that Platform9 manages and introduces the ability to leverage Helm across any of the clusters that you have running in AKS GKE, or the native clusters that we're building as well. And of course, for all good live demos, there's always one that wants to not play nice. I'll give this one extra moment, and there we go. What this has gone and done is gone and connected to this cluster, and it's pulled back all of the Helm deployed applications that are there, as well as any repositories that are in our app catalog over here on the left that could be connected to this cluster and then used to deploy apps. We can see here that this is connected to the Platform9 default repo, and we haven't deployed any of the applications that are in our default app catalog, which we can also touch on in a bit. any app that is deployed, you can also just come in and click edit. It'll pull up an edit screen, and you will be able to change the values.yaml file, click save, and it'll go and update that deployment as it is on the cluster. So I'm going to click back to cluster list and pause here for a second. Just want to see, David, any questions that have come in so far?
Not much. Nope. I'll give you a bit of a time check. We're almost half past.
Time flies when you're having fun.
Yes.
Getting into imported clusters. This is strategically for Platform9, this is something that we've been investing in quite heavily. And our next release, 5.4, is going to add the ability to import all types of EKS, AKS, and GKE clusters, be it on a private or a public VPC. We're creating a Platform9 operator that will go into each cluster and dial home. And that means that if it's on a private network, that cluster will also be able to be brought in and fully managed. We're also working on introducing some extra support for the Profiles engine, which we can also talk on shortly in a bit as well. Whilst we are on the infrastructure and clusters view, I just want to talk about a few of the new additions and changes that we've made here as well. We're always, working with all of our users and listening to feedback. And one of the pieces of feedback that we've received is around health status of clusters and making it a little bit more self-evident about what was going on. So in the 5.3 release, what we've actually done is separate out the health status of a cluster to be a lot more distinct. What we had been doing is rolling up a few of these health elements into one sort of like Uber status. So in 5.3, we've broken out the API server health. So for every cluster that you build or operate that Platform9 manages, the dashboard is going to expose that immediately. Obviously, if you're running a multi-node cluster, this has some resiliency and high availability built in. So therefore has the ability to go into a degraded state. So if this is anything other than green, it means that one or more of the master nodes are unhappy, and our software will be there trying to recover that. In the event that we can't, our support team would work with you to take steps to recover that in real time. The next two statuses here are worth sort of touching on a little bit. We've got a representation here of Platform9 components. To manage a cluster, there's a lot of moving parts that are part of that. And one of the pieces that we install is something called Host Agent. Another piece is a piece of software called Nodelet. And there's also some communication aspects there that create secure tunnels, so everything remains secure and private. And Platform9 components is a representation of those elements and their heartbeats coming back into the SaaS management plane. If, for instance, one of these components is not running, this health indicator here is going to show that the cluster is in a degraded state. If your API server is up and running, the cluster is obviously performing. When our components start degrading, there's a potential there that we won't be able to help restart, say, Docker or another runtime component that's going on in the background. So we split this out here to make it evident about what this was representing and the impact that could have on your cluster. The last piece here is connectivity. If this is red, that means that we've lost the communication connectivity between that cluster, the nodes on it, and the SaaS management plane. That doesn't necessarily impact the cluster itself. What it will impact is our ability to tell you from our SaaS platform, hey, there's a problem with your cluster. And this is something that we would work with our enterprise and growth tier customers pretty quickly to rectify, as if we've lost connectivity, that means we can't help you keep your clusters up, running, and performing as expected. When we drill into the cluster dashboard, we've also continued that data change as well. So we've updated this card in the top left-hand corner and showing it's connected. We're showing the Platform9 component status, as well as the API service. And then in the nodes table here, broken out, this is exactly the same thing. What role is it? Is it a worker or a master? Is everything healthy? And is the API server responding as expected? If one of your nodes is in a state that is unhealthy, the node health view here is a great place to come and click into to see potentially what's not running, or if any of these tasks have been kicked off again. So when we build a cluster, you'll see all of these come through. For a master, there's 24 tasks. For a worker, there is significantly less. And any node that enters an unhealthy state, this will update and take you through the task that it's going. You can also use this view logs button to quickly drill in and see the logs for that node as well. If you want to drill into a node, you can do that directly from infrastructure or from here. Drilling into the nodes page is going to give you an overview of that node with the cluster information if it's in one. And it's also going to give you a little bit of information about capacity. Obviously, everyone's workloads are different, so it's hard for us to say, hey, there's a bare minimum you need to meet. Larger the cluster, more worker nodes, the different types of workloads that go on there will drastically impact what you require for production. But to sort of help users in our free environment, we've introduced a concept of sort of minimum requirements that we know are going to lead to a good experience for using Kubernetes and using Platform9. And we try to call that out to make sure that users, if they are having problems, that this might be one of the aspects that is a problem. So we can see here that this particular node only has 7 gig of RAM. I make that decision. It's in our private cloud, and that was just one of the pre-configured templates that I'm allowed to use. So ideally, increasing that RAM just gives all the applications a little bit more headroom. Disk space as well. Nothing runs well when disk space runs out. Between Platform9 and Kubernetes and different OS components, we know that 30 gig is a good starting point just for the base node itself. Once we get below 20 gig in space between logs and application logs and Kubernetes running, you do start entering a point where we would say, hey, pay attention to this. You want to make sure that node doesn't run out of storage. And you also see this data reported in real time here as well. Clock drift was also added in for 5.3. If there is clock drift, it's important to rectify that. That can cause issues with synchronization with the SaaS management plane. It can also cause issues with upgrades or creating clusters. So we've called that out here as well. So there's some of the, base infrastructure changes that we've made between imported clusters and native clusters, as these clusters represent, and some of the additions we've made to help simplify and troubleshoot our clusters as well. And before we move on to API access, I just want to touch on one last piece that's a change in the 5.3 release. If people have been using Platform9 for a while, you've noticed that the monitoring button has left this table action bar. What we've actually done is we've moved it into the cluster edit. Coming into cluster edit, there's a number of changes about to go live in the next week around managing add-ons dynamically. When you create a cluster, you can choose what to add in, and we're introducing the ability to do that dynamically. And the UI is about to go live, and they're all going to appear here on the edit cluster. So we've moved monitoring here to make it consistent and super easy. Any add-ons will be listed here as a checkbox for enable or disable. When you enable them, you'll see a config prompt card pop up. You can configure them, and there are overrides that are available. Click update cluster, and we'll go and update that cluster for you. So we moved monitoring in here. It is on by default. So if you want to turn it off, either do that when you make the cluster or click edit to do it after. And with that, I'm going to pause momentarily, see if there's any questions from David. And then I think I'm going to bring him into the conversation, so it's not just Chris talking.
Well, it's just so much fun listening to you banter on about
all the stuff
and online things.
Yeah, all the things that our engineering team has been working really hard to deliver. So I'm gonna skip over going to apps and monitoring. We haven't done much changes here at all, so I just encourage people to jump in and have a look and connect a home repository or two. But I'm going to come down here to the API access page and bring in David. David's fairly new to the Platform9 organization. And when he started, this dashboard consisted of telling you the endpoint for your API services and providing you a way to come in and sort of download a kubeconfig. As someone that's in charge of our developer relations, I guess I can ask the question, was that a terribly helpful dashboard?
Maybe a little bit. I mean, I did need to get to kubeconfig, right? But as a developer, you're not doing it very often. So
yeah,
it was nice. The one option I did appreciate in there was being able to get kubeconfig with an expiring token, or being able to get a long-running user-based config. That was an interesting option. I had not seen that before.
Yeah, so you can download the YAML file, which is a long-lived, or copy straight out the kubeconfig here. Yeah. So in 5.3, we're always receiving feedback. People like, what APIs are available, and we put a lot of effort into putting them on our doc site and providing examples of how to use them. But nothing quite beats sort of just having them sort of exposed in the UI that everyone can see. Here's Keystone, that's our identity API, and Kubert, which is our cluster management API. And, across both of them, what's available, what can be done. And these are what we use to make this whole platform work and operate. It's what our users use to automate their platforms and automate clusters. And we thought, let's just make it really easy for people to use. So as part of 5.3, you can now just come in, click get nodes, make API requests, and you actually see the response. The cool thing here is you're actually seeing the request URL. If there's any parameters in there, you either get to interact with it or you get to see the whole thing exposed. So that's get nodes. If I do get cluster details, you're going to be able to come in and just pick a cluster 3. And you've seen here, it's updated this request URL dynamically with that cluster's UUID, which is pretty helpful. It is something you can pull off the infrastructure dashboard, but seeing it pre-composed into a request that you can just click go on and it fail. Not a great demo. Let me choose this one. Make request. And you can see all of that cluster detail information come back.
So let me stay on here for just a second, because this is, I want to introduce a use case that kind of hit me the other day. For those that create clusters and either rely on some of the built-in components that Platform9 offers, like monitoring and things like that, or those that are creating clusters and you don't completely understand everything about creating clusters and all the options and all that, which I'm not embarrassed to say I probably don't understand all the options you could possibly use in creating a cluster. Platform9, if you use our console here to create the cluster, as Chris has been doing, a lot of that you can take for granted, because we do know what it is. Our engineers have taken the time to understand all those options and have put in the opinions about good and bad and what you should use and don't use. So when you go through the UI and you create a cluster, you could treat that as a bit of a starting point, right? I'm going to create a cluster and it's bare minimum kind of cluster, and I want this cluster to be used by developers. So the cool thing is you go in, you create the cluster, get everything right, and then you come over here to the API endpoints and you get cluster details. And all of this that you're looking at, all of this JSON is all the definition of what you wanted out of the cluster, as well as all those deep knowledge opinions in here. So you could take this JSON and check this in to Git or to some repo. And now you can bake it into a pipeline and know that the cluster that you're deploying in that pipeline is best practice and does have good opinions in there, but is also tailored to what you're running as. So it's this one really kind of hit me because it's like we're showing you, here's the entire configuration for it. Now take this and you can go automate with it, do other things. That was a pretty powerful thing for me. I'm already using it.
Yeah, I mean, I think that's a great use case of using our APIs and something that otherwise would have taken a few extra steps prior to 5.3. Someone would have had to come in, get a Keystone config, and then go to our doc site, figure out the documentation on what's available in Kubert, and then set up an environment and connect to it and get that response. So hopefully this does help people. Just to touch on our API, there are some nuances. We have multi-tenancy, and what that means is you'll quite often see things referred to as a project. A project is a tenant. Keystone projects will give you that response, and it will give you information about that project. It also has the ID, which is available here. That's one way of getting it if you're using our APIs. The other way is just come into the admin console here, go to admin settings, and under tenants, if you don't see the UUID here, just use the config here to turn it on. A lot of the APIs will use this in the URL. If I go back to API access and to Kubert, a number of these will automatically insert that for you. So that's just a quick intro into the APIs and what we've changed in 5.3. So hopefully this is useful for people. Love to hear feedback. The last piece that we've brought in to change on this page as well is exposing our Terraform providers, just making it super evident in the products that we do have Terraform providers that we build and test and keep up to date, available for AWS and Azure. So if you want to check them out, head to GitHub, Platform9/conform, or if you're in the UI, just come in and click the link and it will take you straight to them.
And I'm right now in the midst of the Terraform, in the Terraform services marketplace. We're listed in there, but it's just not very good. It's very, very minimal what's listed over there. And so soon you will be able to go into their services marketplace and see a whole breakdown of documentation and optional things or required things and example strings and all that good stuff. I'm in the midst of building that now.
Cool. All right. I think with the remaining time we have, I'm going to shift to an area that we've been investing in a lot, and that's what I touched on at the top of the session, which is Profiles Engine. Profiles Engine is a new piece of functionality that Platform9 is building out, and what we're creating is a way to help almost templatize clusters. What David touched on the API there, and they get clusters, you can see that config. What we're building with the Profiles Engine is the ability to take those configs, save them as a template or a profile, and then reuse them straight out of the Platform9 ecosystem. That means building clusters, configuring add-ons, and importantly, different Kubernetes policies. And with 5.3, we're about to release the ability to manage role-based access control using the Profiles Engine. I don't know, David, if you've ever gotten into the world of Kubernetes RBAC or just always just consumed what's there, but I personally don't think it's very easy.
No, I can attest to that. It's not very easy. If you've ever gotten into either consuming controllers like that Prometheus stuff and the Grafana stuff and all that. If you ever gotten any of that, you have to hook up RBAC. And when you go in and look at the YAML for that RBAC, you're scrolling. It's just no fun.
Yeah. So
this is much nicer. It's just an easier visualization, at least. You know, I mean, RBAC in general, you've got to understand some core values of it, of the point of it. But this at least gives you an easier visualization of it.
Yeah. So we've had this for a while now. If let's say someone's looking after multiple clusters and they come in and they spend a few hours or a few days or weeks going through and they set up that cluster and they're like, all right, I've got everything I need. I'm going to, I don't know, export all of that, store it in GitHub, and then all of my clusters that come up, I'm going to then go and reapply them. But then how do I know that it's actually done, that this is what it says it should be? You can hope that your pipelines and your deployments are operating as expected. But to go and manually check that is going to be quite a lot of overhead. And that initial upfront investment is also going to be quite burdensome. So to simplify that, to automate it, and make it accessible to anyone that's using Kubernetes, not just a Kubernetes master that's been using it since 2017 or earlier, we have introduced the profiles engine. I'm going to use slides for 5 minutes here to introduce this concept. So the profile engine will in the future be able to take a snapshot of your cluster's configuration and template all of that. Any add-on that we have in the product, as well as any override configs for those add-ons, will also become part of a profile engine. And what we've released in 5.3 is role-based access control profiles. And what we're doing is enabling you to come in and basically take a snapshot of the roles and cluster roles that are important, as well as their associated role bindings and cluster role bindings. You don't have to do the whole cluster, and you can visually come through and select each one that you want to snapshot and say, Platform9, let's make that my profile for production, and then help me simply deploy that across all of my clusters and then manage that state and governance compliance moving forward. So that's what we've built in. I will be doing a short demo after these slides. Just to get everyone on exactly the same footing here. This is a new concept, so I want to make sure I explain the nuances that we've built in. So we've built a profile. We've said, here are all of the policies that I want from RBAC in that profile. Once we do that, it's created in what we call a draft state. A new profile always gets created as a draft, and you're not able to deploy that to a cluster. The reason we've done that is we want to make it quick and easy to create a profile. And then you could go into a profile that's in a draft state and say, hey, I want to publish that so I can now go and deploy it to clusters. It also means that if you're halfway through making it, that no other administrator or user of Platform9 is going to come in and be like, oh, cool, that's ready to go and deploy it, right? And maybe you're on vacation, you come back and you're like, the world's on fire. What happened? Like, oh, we deployed it. We thought it was ready and it wasn't ready. So the draft state is where we create all profiles into. Once it's published, it goes into the published state, and you can now use that profile to start governing your clusters and to deploy them. The end of the life cycle for a profile is either deleted or archived. Maybe you've used it and you just want to keep it around for reference sake. That profile you can say is archived, which means it's there, it's read-only, you can see what it's made up of. You could clone it into a new profile to use it again if you wanted to, but you can't deploy it to a cluster. So how do we make these? I'm just going to click escape. I'm going to go to my development platform where I've got this up and running and go through it super quick. So you will see an introduction of a new tab here called Cluster Profiles. There'll be a big blue button that says Create a RBAC Profile. You can come in and say, I want to make my production RBAC policies. Step one is you choose a cluster that you want to use as a base. So I'm just going to choose this one. Click Next. The next 4 screens are all about consuming and selecting which existing RBAC policies on that cluster you want to bring in. You can filter by namespace, obviously for roles, makes a lot of sense. And if you want to view what's in these, you can click the plus button. Now, we made a decision here to not allow editing. RBAC profiles and RBAC policies can get quite complicated, and we wanted to split the create step and the edit step into 2 very distinct things, and that's why we have that draft state. So you can view all these policies, and you can say, all right, I like all these system ones. I know they want all of them in there, and I want Kubernetes dashboard. Next, same with our cluster roles, right? These are things that are not namespace scoped for people that are learning Kubernetes. Next, you can come in and choose role bindings. Next, and same with cluster role bindings. Obviously, I'm just randomly picking things here for demonstration purposes. You then get the review and summary, where you can see what's been added into this profile. So this is essentially step 1. I'm making this RBAC policy. I've chosen a base cluster, and I'm going to click done. When you do that, we're going to connect to the profile agent that's on the cluster. It's going to collect all those policies, and it's going to go off and try to snapshot them, return them to the SaaS management plane, and save them. These are all in errored state because this is a development platform. Once that finishes, what will actually happen is, I don't need to go through that, is you'll have a profile that can be edited. So I'm just going to click present again. To finish publishing that profile, you might not need to do anything. What you can do with the edit state is to come in and edit each one of those policies individually. So just like that dashboard I was just showing for role-based access control, exactly the same features. You can tune them to what you need. And you can also add any policies from any other cluster, or switch to a YAML view if you like, and bring in anything that otherwise is maybe not running in a cluster today. So we give you the ability to edit what you added in the creation step, give you the ability to add anything from other clusters that you might have running in your environment that you want to make part of this profile, or just use straight up YAML to finish creating that profile. Same steps for cluster roles, role bindings, and cluster role bindings. So choosing your users, your groups, your service accounts, adding users from Platform9 as role bindings and cluster role bindings, or Platform9 groups. And if you've got single sign-on set up through Platform9 and the managed clusters, adding those SSO groups as well. So bringing all of that governance and control into one spot. Once it's in the state that you want, just simply click publish. That'll make it available to deploy. To deploy a profile will be super easy. Just choose the one you want to deploy, click deploy. It will tell you, the profile name, what's in it. It will also tell you whether or not the agent's installed on that cluster. If it's not, we'll add it. If it is, you'll be able to deploy that cluster. And here comes in some of the stuff that we're hoping will be very valuable to users. If you want, you can just click deploy, and we'll tell you, are you sure you want to do this? Without knowing what the impact is, you can click yes, it will go and do it. If you click impact analysis, what it's going to do is it's going to use the profile agent to look at all of the RBAC policies, create a snapshot, return it to the SaaS management plane, and do a diff analytics, which is what we're calling drift analytics for role-based access control. And it's going to give you a report of sorts about how that cluster is different to the profile that you're about to deploy. And this also works once a profile is deployed onto a cluster. You can say, oh, hey, how does this cluster compare to the profile that's running, or any other profile as well? So on this screen, you'll be able to compare and look through roles and cluster roles, bindings and cluster role bindings. You'll be able to say which API groups have been changed, or what verbs have been changed, and when necessary, take action to rectify that. Or you could say, hey, wait a second, these are all relevant changes that have been made in my development environment that I need to promote to production. I'm going to add them to the profile, click save, and then deploy them out. So when that application goes live, it's starting there with all the right policies in place. Conversely, if changes have been made in lower environments that have not been promoted to production and you run into a problem, this is a really quick way to come in and sort of say, hey, are there any RBAC policies that are causing issues between test, dev, staging, production, A/B deployments, what have you? Hey, Platform9, help me see if there's a difference here, right? So you could just completely create a profile on your dev cluster and then go to maybe staging and say, hey, Drift Analytics compare, and we'll visualize everything that's different between those two environments, from the roles, the APIs that are within them, the namespaces they're scoped to, as well as the verbs that they have access to. So maybe there's a bunch of green and there's things that are in the development environment that aren't there in staging, or maybe there's a bunch of things that are red. And that'll immediately help you pinpoint, wait a second, right, there's been a change in this environment that also needs to be managed.
Hey, Chris.
Yep.
We got about 5 minutes left. If you could humor me, I don't want to cut in too much if you've got other stuff to show, but the RBAC template and all that, I'm just trying to find a good place in my life for it, right? And give some context. And if you wouldn't mind humoring me for a few minutes.
Sure.
And so what I get RBAC and I get all the components there of it. But as I try to put it into my world, I want to explain to you what I'm kind of visualizing, and it's a model that I understand very well. It's a tried and true model, and I'm thinking about RBAC and this template and everything in kind of the same way, and that is databasing, right? So when you create a database, let's say we're doing a MySQL database, and we have a staging environment and a production environment. So we're running the database between a different instance of a MySQL database in those two environments. When you create that database, really, when you've added a few schemas in there and you add users to them, you have to give the users privilege, right? And in a database, there are all kinds of granular privileges: list rows, select rows, add new tables, add new rows, update rows, all those things, all those rules. And you create profiles, and you give users, a group of rights, right? A developer in the staging database can add new tables and add information in any table, but a developer in the production database can only audit those tables. They can't actually add any information in, things like that. And so that's kind of where my mind is going when I'm looking at this. I'm saying, I'm going to create this thing in production. And let's say I create this database and everything in production, and I create all the roles or the users for it. And then that's my model. And then I'm going to pull all that SQL out, and then I'm going to go back to staging, and I'm going to recreate that. And then I'm going to augment it a little bit because it's in staging. And this is kind of the way I'm seeing this RBAC templating is create it in your production environment, a template for what you want these roles to be. And then take that over to your staging cluster and apply it and see what has changed and monitor that. Would you agree with that kind of thinking, that correlation? Am I close?
Yeah, that's essentially what we're trying to get to. The evolution of this will be introducing the ability to store these profiles on GitHub or other repos. So then they really become part of your as code approach to managing everything, GitOps for lack of a better term. And it's helping to standardize what's running and what's operational. We're also going to be introducing the ability to say, when I deploy a profile, how do I want Platform9 to help manage that state? If this is my known state, do I want Platform9 to say, hey, we're super strict, everything's as code. If something changes on the cluster, just override it based on what is stored in that profile, because that's how this cluster is meant to run. Or hey, send me a notification saying, hey, something's changed. So then if you aren't taking that approach of saying, I'm going to go from production to staging because I want to deploy and test everything thoroughly first, you can then say in staging, hey, run, but only notify me when there's changes. So then all of a sudden, if there's a new deployment that comes out or your test suites are going, or maybe you've got some UAT or business testing or whatever practices people use, you can see there before it gets to production that there's a change. It was potentially made for the application to perform, and will notify you when that change has happened. So then you can make that decision. Hey, is this allowed? Is this kosher? Do we want this in production? Or is this something we need to go back and make sure that we handle before we deploy to production because we're not making that change?
Right. And I have to say, from a security standpoint, this is a pretty significant feature, I think, because your clusters in production are locked down, right? Nobody runs loose clusters for production, or you just don't. And so having that and software defining that, and in Kubernetes, that's pretty much a given, having that software defining that, and then having something watch that the state has drifted. The state is not what I software defined it as. Notify me or just rectify it, do it right now. That's from a security standpoint, that's a pretty big deal.
Yeah, I'm really looking forward to getting the team onto the enforcement engine. I don't know if I'm going to call it that. Seems a bit strict, but yeah, the abilities to make use of this and help further automate people's lives. I think adding
analysis, RBAC analysis engine. How about that?
Yeah, let's call it that, and then we can do anything. I like it. And I think adding repos will really help as well, right? I think allowing people to store these profiles, not just on our SaaS management plane, but in their repo next to the rest of their code. So if they want to ask the question, hey, well, what is there? I want to look at the YAML file. They can. It also
there's nothing proprietary to Platform9 in there. Let's be clear about that. It's a real RBAC definition. You can go anywhere you want with it in a cluster.
Correct. Cool. We are at the top of the hour, and I am back to back today. So I'm going to click stop sharing. Man, that's a lot of stuff in 5.3.
That's a lot of stuff in 5.3. Yeah, can't wait to get started.
Yeah, let's thank you everyone for attending, and we'll post this to YouTube as we do with all of our videos. In 2 weeks, we'll have another Fortnight session. So looking forward to it.
Okay. Thanks, everybody. Thanks, Chris.
No worries.